Welcome to this video segment. Today we shall balance chemical reactions using the algebraic method. The last time we did inspection method. Today we are going to do algebraic method. Please, before you move on with this video, I will suggest that you view the video on inspection method. It is very important. Okay, let's look at the chemical reactions that we are going to balance using the algebraic method. In the first one, you have two reactants and one product. In the second one, you have two reactants and two products. In the third one, you have two reactants and two products. In the fourth one, you have two reactants and three products. Now, algebraic method has a technique, and the technique is that when we have two reactants and one product, we place variables. Variables are alphabets. Okay, we place variables in front of these reactants, and then if it's only one product, we don't place any variable here. We don't. Now, if we have two reactants and two products, we place variables in front of the two reactants, and we now place a variable in front of one product. Not the two products, but one product. Remember, if it is only one product, we don't place any variable. If it is two products, we place the variable in front of one product, just one of them. Okay? The same thing goes with the third one. We place variables in front of the two reactants and also in front of one product. Then, if we have two reactants and three products, we place variables in front of two reactants and two products now. Okay, two products. Instead of the three products, we place in two products. So if you have only one product, you don't place any variable. If you have two products, you place the variable in front of one. If you have three products, you place the variable in front of two. If you have four products, you place variables in front of three. And that's the way it goes. All right, let's go ahead. First one, we have sulfur 4-oxide, which is a gaseous form, combining with oxygen, which is the gaseous form, to give sulfur 6-oxide in gaseous form. Please, like I said, I would suggest you view the videos on inspection method. We talked about S being solid, L being liquid, AQ being aqueous, and G being gas. Okay, so just view that video, please. All right, so for the algebraic method, we will place variables in front of the two products. We can say X, Y, in front of the two reactants. We place variables X, Y in front of the two reactants. And because we have only one product, we leave it. We leave it. So we now use inspection and write what each of these means. Sulfur, oxygen. The same thing here, sulfur, oxygen. Sulfur here is X. Okay? And oxygen is 2X here plus 2Y here. 2X here plus 2Y. 2 times X is 2X plus 2 times Y, 2Y. So we have 2X plus 2Y. Here, sulfur is 1 and oxygen is 3. So we now do it algebraically. What do I mean by that? You equate S to S, so X to 1, and then O to O. That is 2X plus 2Y to be 3. So from here we find that our X is 1. From here, X is 1. And then we also find that 2X plus 2Y is equal to 3. Okay? So our X is 1. So this is 2 times 1 plus 2y equal to 3. So this is 2 plus 2y equal to 3. 2y will be 3 minus 2, 2y will be 1, and then y will be 1/2. So our x is 1 and our y is 1/2. Right? X is 1 and y is 1/2. So we just plug it in here. We now have 1 SO2 plus 1/2 O2, oxygen, right, to give SO3. Now, because we have a fraction 1/2, the LCD is 2. LCD becomes 2. So you want to clear this fraction. So you multiply every term by 2 to clear the fraction. You multiply every term by 2. Multiply all the reactants by 2, each of the reactants by 2, and also the product by 2. So when you do that, you now have 2 SO2 plus 2 times half is 1 O2 to give 2 SO3. And this becomes balanced. Now if you want to check it, if you want to check by inspection, you check by inspection. Yeah, everything we do, we will check it by inspection to make sure it works right. We have the sulfur and the oxygen here. Reactants, we have the sulfur and the oxygen products. Sulfur here is 2, oxygen is 2 times 2, 4, plus 2 is 6. Sulfur here is 2, and oxygen is 6. So this is the balanced reaction here. So now let me kind of review it, talk a little bit about algebraic method. This method is the best method. It balances any chemical reaction, any one. No matter how complex the chemical reaction is, it balances any chemical reaction. So, and one good thing about it is that after balancing it, you can check by inspection to see that you did it right. Yeah, that's one good thing about it. So, we will go ahead and move on to the next one. Remember what I did? I placed variables here, and I equated those variables. So it's kind of, we are using variables and then we do inspection, and then we solve algebraically. Okay. Of course, one good thing is that you should also be able to solve linear equations. You should be able to solve linear equations. That's why we call it the algebraic method. And when you're done, you don't want to have fractions. You want to clear the fractions. So you multiply by the LCD. And then you now check by inspection. All right, let's go ahead and do number 2. Number 2, we have butane, C4H10, butane gas, combining with oxygen. That is the combustion of butane. Combustion of butane to give carbon 4 oxide and steam. Steam is gaseous water. Now, it's difficult to do this by inspection. When you start it by inspection, you will understand what I'm saying. So, the easiest way to do it is algebraic. Algebraic comes in when inspection does not work, or when inspection method proves difficult. Algebraic comes in. But algebraic does it straight away. I mean, it will balance it immediately. Okay, so let's go ahead and try to balance this. We find by inspection, we have a carbon, hydrogen, and oxygen. And the same way we write it here, carbon, hydrogen, and oxygen. Okay, we place our variables. We can place x, y, and then z. Now this is my z. I write my z like this. See? Okay, you don't place any variable here. So let's go ahead. C here is 4x. H is 10x, and O is 2y, right? So Z, C here is Z, H is 2, and O is 2Z plus 1. 2Z plus 1. So if we look at this, what is the easiest way to start from? Okay, 4x is equal to Z, 10x is equal to 4x is equal to Z, 10x is equal to 2, and then 2y is equal to 2z plus 1. So which one is easier to start with? Let's find x first. X is easier. So we can call this equation 1, equation 2, equation 3. This is now algebra. So we can say from equation 2, we have that 10x is equal to 2, so x will be 2 divided by 10, and x will be 1 over 5. So we found our x. So we now substitute for x in equation 1. From equation 1, we now say that 4x is z, so that means that z is equal to 4x. You substitute. X is 1 over 5, so you plug it in, you substitute. So z will be 4 times 1 over 5, and z will be 4 over 5. Okay? So our z is 4 over 5. And then we can now find our y from equation 3. So we come over here, from equation 3, let me kind of draw this like this to separate it. From equation 3, 2y is equal to 2z plus 1. So our z is 4 over 5. So this is 2y equal to 2 times 4 over 5 plus 1. 2y will be 8 over 5 plus 1. 2y will be 8 over 5 plus 5 over 5. 2y will be 13 over 5. And then you multiply both sides by 1 over 2, or you divide both sides by 2. So y will be 13 over 5 times 1 over 2. You can also use the LCD, multiply by the LCD, and then 10y will be 13, and y will be 13 over 10. So y will be 13 over 10. If you're confused, you can, here you can also multiply by the LCD. LCD is 5. Then 5 times 2, 10y equal to 5 times 13 over 5 is 13. 10y equal to 13, then y equal to 13 over 10. Okay? So we found x, y, and z. So now let's go ahead and plug it in here, and then we check by inspection. Okay? So I'm just going to clean this so I'll have some space. Right? So we just plug it in here. Our x is now 1 over 5. Our y is 13 over 10. And our z is 4 over 5. Alright. So let's go ahead now and check by, let's first of all clear the LCD. What's the LCD here? We have 5 here, we have 10, we have 5, and we have 1. So the LCD is 10, right? LCD is 10. So if we multiply 10 by everything, 10 times 1 over 5 will give you what? 2. So we have 2 butane plus 10 times 13 over 10 will give you 13 of the oxygen, to give 10 times 4 over 5. Let me just do it here. 10 times 1 over 5 will give you 2. 10 times 13 over 10 will give you 13. 10 times 4 over 5 will give you 5 will cross out 2. 2 times 4 is 8. So this is 8 carbon dioxide plus 10 times that will give you 10. 10 steam. And that's the balanced reaction. Now we can check by inspection. Check by inspection. And when we check by inspection, we have CHO for the reactant, and we have a CHO for the product. So for the reactant, carbon is 4 times 2, 8. Hydrogen is 10 times 2, 20. Oxygen is 13 times 2, 26. Here, for the reactant, carbon is 8. Hydrogen is 2 times 10, which is 20. And oxygen will be 2 times 8 here, 16, plus 10 here, 26. And you see it's balanced. So, algebraic method. But if you were to do this by inspection, it will take you a long time. So, but with algebraic method, you're very sure that once you do it, you'll get it right. All right, we're coming there. Let's do another one that looks like these 2 reactants and 2 products. Now, I'll probably will erase this too, because I might need this space because of the algebra. All right, the next one, number 3, we have iron hydroxide, iron 3 hydroxide, solid, reacting with a tetraoxosulfate 6 acid, of course, which is aqueous. That is an aqueous solution, to give you iron sulfate. Iron sulfate is the old name. The IUPAC name is iron 3 tetraoxosulfate 6 and water, liquid water. So this is solid and then liquid water. So iron 3 hydroxide combines with tetraoxosulfate 6 acid, to produce iron 3 tetraoxosulfate 6 and water, liquid water. So we have iron, we have oxygen, we have hydrogen, we have sulfur. The same way here, we have iron, we have oxygen, we have hydrogen, we have sulfur. Iron here is 1. Oxygen is 3 here, 3 here. Okay, before we do that, I'm sorry. Before we do that, we have to place our variables, okay? So I was even doing inspection already without noticing I'm using algebraic method. Don't mind me. Okay, this is X. Let's put X, Y, Z. Now you can use any variable you like. Okay, it must not be X, Y, Z. You can use any variable you like. So iron here is X. Okay. Oxygen is 3X here. 3X here plus 4Y here. So we have 3X plus 4Y. Hydrogen is 3X here plus 2Y. So we have 3X plus 2Y. And sulfur here is Y. Y. Then here, over to the products. Iron is 2Z. Oxygen is 4 times 3 is 12. 12Z plus 1. 12Z plus 1. Hydrogen is 2. And sulfur is 3Z. 3Z. Sulfur. Okay. All right, so we have that our X is equal to 2Z, equation 1. 3X plus 4Y is equal to 12Z plus 1, equation 2. 3X plus 2Y is equal to 2, equation 3. And then Y is equal to 3Z, equation 4. So this is not really like your ordinary, some of the questions you see in math, but it's the same principle. Okay, it's the same principle. We have to find out what X, Y, Z are. So, looks like we'll be running into some simultaneous equations. That's systems of linear equations. So you may need to view, you will need to view that video as well before you continue here. Systems of linear equations in two variables. Because that principle is what we are going to use here to solve this. All right, where do we start? We can substitute equation 1 and equation 4 into equation 2 so that we can find Z immediately, easily. Okay, like what I'm saying, you know, from equation 1, X is 2Z, and then from equation 4, Y is 3Z. So we can pretty much substitute it here, and then we have in Z, 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 and then we can easily get Z. And once we get Z, then X and Y will be very easy to get. So let's say substitute X is equal to 2Z and Y is equal to 3Z into equation 2. Or you can also say it like this. Substitute, you can say it like this. Substitute equation 1 and equation 4 into equation 2. You can have it this way. So if we do that, we now, of course, our equation 2, we have that 3x plus 4y equal to 12z plus 1. So, but our x is 2z. So this is 3 times 2z plus 4 times, our y is 3z. 3z equal to 12z plus 1. So this is 6z plus 12z equal to 12z plus 1. So you move. Remember how we do linear equations. It's important. So this is a 6z plus 12z minus 12z equal to 1. Of course, 6 plus 12 is 18. Minus 12 is 6. So 6z is equal to 1, and our z will be 1 over 6. So we've got our z. And when we got our z, then we can now use from equation 1, x is 2z. So x will be 2 times 1 over 6. So x is 1 over 3. And then from equation 4, y is 3z. So y will be 3 times 1 over 6. So y will be 1 over 2. So we've got our x, y, and z. Okay? So let me now, I have to erase this now so I can still check this stuff. So our x is 1 over 3. Our y is 1 over 2. And our z is 1 over 6. So if we look at 1 over 3, 1 over 2, 1 over 6, LCD is what? LCD is 6. So we multiply everything by 6. So 6 times 1 over 3 will give us 2. 6 times 1 over 2 will give us 3. 6 times 1 over 6 will give us 1. And then 6 times 1 will give us 6. Because that's, here is 1. So we just plug it in. This is now 2 Fe hydroxide, iron 3 hydroxide plus 3 tetraoxosulfate 6 acid to give 1 iron 3 tetraoxosulfate 6 and 6 moles of water. 6 moles of water. 2 moles of this plus 3 moles of this to give 1 mole of this plus 6 moles of that. Okay, so let's now check by inspection. Check by inspection. We have our iron, oxygen, hydrogen, sulfur for the reactants, and we have our iron, oxygen, hydrogen, sulfur for the products, right? So iron is 2 here, oxygen is 3 times 2, 6, plus 4 times 3, 12. 6 plus 12 is 18. Hydrogen is 3 times 2, 6, plus 2 times 3 here, 6. 6 plus 6 is 12. Sulfur is 3. 3 here. Okay. Then here iron, excuse me. Here iron is 2. Oxygen is 4 times 3, 12, plus 6, 18. Hydrogen is 2 times 6 is 12. And then sulfur is 3. So it's balanced. Algebraic method, and then we check by inspection. Alright, let's do the one that has 3 products. Okay, let's do the one that has 3 products, and then we'll call it a day. And I will just erase this as well. So the last one, we have copper reacting with a nitric acid. Nitric acid is the old name. Solid copper plus aqueous nitric acid, which is a trioxide 5 acid, or hydrogen nitrate, which is trioxide 5 acid. To give copper trioxide 5, plus nitrogen 2 oxide, gas, and liquid water. Okay? Alright. So now let's list them: copper, hydrogen, nitrogen, and oxygen. The same thing here: copper, hydrogen, nitrogen, and oxygen. So we now put variables. Okay, we put variables here. We can put x, y, z, but we know, we have to put another. We have to put 2 variables here. We have to put 2 variables here. So we must not use x, y, z. We can use let's say we say a, b, c, d. How about it? A, B, C. Or let me, because this C will be confusing with the copper. Let me put this as D, and then let me put this as K. K. Just put anything that you know. K might be confusing. Let me put X here now. X. Okay. And then remember, I have to leave this. Okay. So we can now write our copper is A, right? Then our hydrogen is B here. Nitrogen is B. And oxygen is 3B. Then here our copper is D, right? Hydrogen is 2. Nitrogen is 2D. 2D here plus X. 2D plus X. Okay? And then our oxygen is 3 times 2 is 6. 6 times D. 6D. 6D plus X plus 1. 6D plus X plus 1 will be our oxygen. Alright? So let's go ahead. This is A equal to D, B equal to 2, B equal to 2D plus X, and then 3B equal to 6D plus X plus 1. Equation 1, equation 2, equation 3, and equation 4. Alright, we look at this now, and we see already that our B is equal to 2, which is good. Then we see that we'll be stuck here. We'll be stuck here. Here we have a B, but we have D and X, and then here we have B and we have D and X. So it's pretty much that we will combine equation 3 and 4 and solve it as linear systems. Okay, and solve it as linear systems. So we just substitute, okay, substitute equation 2 into equation 3. We now have that 2 will be equal to 2D plus X, okay, and we also have substitute equation 2 into equation 4, and we have that 3 times 2 is equal to 6D plus X plus 1. So which is 6 is equal to 6D plus X plus 1. So let's get these two together now. We are going to solve linear systems. 2 is equal to 2D plus X, and 6 is equal to 6D plus X plus 1. So of course, like I taught you, we want to do this to 2D plus X is equal to 2, and call it equation 3, no problem. Okay? And then here we say that 6D plus X plus 1 will be 6. So 6D plus X is 5. Call this equation 4. So actually we have 2D plus X equal to 2, equation 3. And then 6D plus X is equal to 5, equation 4. Okay? So we can go ahead and get let's subtract equation 4 minus equation, let's do equation 4 minus equation 3. Equation 4 minus equation 3 gives what? 6D minus 2D, because this is X, this is X. 6D minus 2D is 4D. And let me just erase this right away. 6D minus 2D is 4D. Then X minus X is 0. And then 5 minus 2 is 3. So D will be 3 over 4. D is 3 over 4. Okay? So let's find our X now. We can find X using, now what I did was elimination. So I can also try another elimination, but I don't want to. I want to just use substitution since we found D. So go ahead and substitute. So substitute D equal to 3 over 4 into equation 3. So we have that 2 times 3 over 4 plus X is equal to 2. So this is 6 over 4 plus X is equal to 2. Move this over here. So X will be 2 minus 6 over 4. 2 minus 6 over 4. Right? So continue. X will be 2 minus 3 over 2. So X will be 2. This is 4 over 2 minus 3 over 2. So X will be 1 over 2. X is 1 over 2. So we found X, D, B. And of course our A. Our A is equal to D. So our A is equal to D. So our A is equal to 3 over 4. So we found B. Our B is 2. AB, XD. And then we are good. So we can go ahead and plug it in and check. So if we actually plug this in, our A will be 3 over 4. Our B will be 2. Our D will be 3 over 4. Our X will be 1 over 2. Our X is 1 over 2. And then this is 4. So what's the LCD now? You have the fraction LCD. LCD is 4. Okay, so multiply everything by 4. 3 over 4 times 4 will give 3. Then 2 times 4 will give 8. Then 3 over 4 times 4 will give 3. Then 1 over 2 times 4 will give 2. And then 1 times 4 will give 4. So let's finish it. So this is copper plus 8 nitric acid to give 3 moles of copper nitrate, copper trioxide nitrate 5, and 2 moles of nitrogen 2 oxide, and 4 moles of water. Okay. And this is the balanced equation. You can now check by inspection. Check by inspection. We have that copper, hydrogen, nitrogen, oxygen, copper, hydrogen, nitrogen, oxygen. So copper is 3 here, hydrogen is 8 here, nitrogen is 8 here, oxygen is 3 times 8, 24. Here copper is 3, hydrogen is 8, nitrogen is 2 times 3, 6, plus 2, 8. And then oxygen, 3 times 2 is 6, 6 times 3 is 18. 18 plus 2 here is 20, plus 4 here is 24. So, and that's it. Alright, thank you, my viewers. Thank you for listening to this topic on balancing of chemical reactions using algebraic method. For a moment of conscience, I have a question to ask. I have noticed for some time now things that are going on, and because of that, I have this question to ask so that we will just think about it. Can someone who is poor, or let me say, can someone who does not have money be the president of the United States? Is it possible that someone might not have a lot of money, okay, maybe average or below average, but the person is committed to making this country progress, okay? The person has the perfect ideas for the success of this country. Can the person ever be president? Please ask yourself that, because from the way things are going, it's like it's only when you have so much money, or when people donate millions of dollars, okay, and when they donate all these millions of dollars, they fund campaigns. Do you think their ideas will not come into play? I mean, they give all these millions of dollars. You don't think that they just give it away? They will always pursue their interests, and their interests may not be for the betterment of the masses. You see, so money and conscience. Just a moment of conscience. Think about it, okay? And think about it very, very well. All right. Thank you, guys. Thank you, ladies. Thank you, everyone. As usual, I'm Samuel Chukwuemeka, and you have a great day. Bye.